Discussing about the RMS value of the alternating current, we define RMS value of the alternating current as the amount of steady current which will produce the same amount of heat in a particular time as is produced by the AC for the same amount of time. But here we define RMS for a full cycle, not a half cycle. So when we will integrate the equations, we will integrate from 0 to t, not 0 to t by 2 as in case of the mean or the average value. Let us take the value of I be equal to I0 sine of omega t be the instantaneous value of the current. I0 is the peak value or the amplitude of the current, and the waveform is sine that the waveform is starting from the 0. For a small amount of time dt, let us take the alternating current to be constant. So for a small amount of time dt, let dH be the heat produced. That dH will be heat produced will be equal to I square. R is the resistance of circuit and time is dt. So dH will be equal to I0 sine of omega t whole square into R dt. So dH will be equal to I0 square sine square omega t R dt. This is a small amount of the heat produced in a small amount of time, that is dt. Now we have to calculate what is the total amount of the heat produced from 0 to t. So we will integrate this from 0 to t, integrating dH, that is equal to integration of 0 to t I0 square sine square omega t into R dt. This and this goes, so heat produced will be equal to, taking the constants out of the integral sign, so we have I0 square into R integral of 0 to t sine square omega t dt. We have H is equal to I0 square R integral of 0 to t 1 minus cos of twice omega t divided by 2 into dt. Taking this 2 out of the integral sign, we have H is equal to I0 square R divided by 2 integral of 0 to t dt minus integral of 0 to t cos of twice omega t dt. Now here we have H is equal to I0 square into R divided by 2 integral of dt is t from 0 to t minus the integral of cos 2 omega t is sine of twice omega t divided by 2 omega from 0 to t. Now solving this, H is equal to I0 square R divided by 2 into t minus 0 minus 1 by 2 omega out of this, and we have got sine of twice omega into t minus sine of twice omega into 0. We are left with H is equal to I0 square R divided by 2 into t minus 1 by 2 omega. Here we have sine of 2 into 2 pi by t into t minus sine 0 is equal to 0. Here t and t goes. We know that we are left with sine of 4 pi, and we have sine of n pi is equal to 0. Sine of n pi is equal to 0. So this term comes out to be 0. We are left with the heat produced equals to I0 square R divided by 2 into t. Now if IRMS is the value of root mean square current, so the heat produced during the time t will be equal to H is equal to IRMS whole square into resistance into time. As this heat produced and heat produced is the same, so we have IRMS whole square RT is equal to I0 square RT divided by 2. T and T goes, R and R goes, so IRMS equals to I0 divided by root 2. So the value of IRMS is 1 by root 2 times the peak or the amplitude of the current. Taking it magnitude wise, we have IRMS is equal to I0 divided by 1.414, that comes out to be 0.707 I0. So the IRMS value is equal to 0.707 times the peak value or the amplitude of the AC current. Now taking percentage wise, we have that IRMS is equal to 70.7% of I0. So we also have that the RMS value of the current is equal to 70.7% of the peak or the amplitude of the AC current.